Welcome back to the video lecture series on Python programming. We are going through the Python libraries and we have gone through a very important library, the NumPy library. Now, we are going to cover another very important library, which is the Pandas library. Primarily, the intent of the Pandas library is to do all the data related stuff, right? The data manipulation, the data loading, then manipulation, saving the data, and all the different tasks related to the data, right? So, first of all, pandas, I mean, how does the name come from? So, the pandas name comes from the short form. It's basically a short form of panel data, and as I told, it basically supports and enables data manipulation related activities, right? It provides a fast way to work with uh, all the relational data or the structured data. So whenever we talk about data in machine learning or deep learning, we have two types of data. One is structured data, which has a very clearly defined format and all those stuff. I mean, rows and columns. So that kind of a very clear format is there. So those are called structured data, and the ones which don't follow that kind of a format, like the text data. So those are called unstructured data. So Pandas library provides important functionalities to work with relational and structured data, right? Now, how do you start working with pandas? Simply in the same way as we have done for the other library, that is the Python, so that is a NumPy library. We simply do a import pandas as PD. Okay, as PD means simply we are doing an alias, so that we don't have to use pandas every time we want to call a function. We can just use PD and then call the function PD dot function name. Okay, now, when we actually start working with data, the data can be coming from either of the two sources. Either we can have a different data structure like a NumPy array or a list. From that, we create the data. And in Pandas, the data structure for storing this data is called data frame, right? So data frame object is the one. So either we can create the data frame object from NumPy array or from Python list. So that is one way. Other option is to get the data or load the data from a data file. Okay, so say for example in a CSV or a comma separated file, right? So we have the data in the CSV file. From there we load the data into the Python data frame object, right? Data frame object. So that is the other way we can do it, right? So let's try to explore each of the options. I mean, the Python data frame object created from lists, or similar way you can do it for the NumPy array, and Python data frame objects created from the CSV file. We can also go for other file formats, but for this particular exercise, let's just focus on CSV file. Okay. So we come back to the Google Colab, and we first start with the import of the pandas library. So import pandas as PD. So we do that. And when we run that, obviously the first time it takes a bit of time. So we will get the pandas library functions. I mean, already, on, I mean, we can get in the Google Colab console, right? And we can start using them. So basically what we do is we will create a pandas data frame object from list. Okay, so how do we do that? Let's create the lists first, right? So lst1 equals, and then we give the list value. Say the first one, we have the different numerical values, right? So 12, again, say 17, 34, 43. Again, we give a 12, so 25. Okay, all the integer values we give. Okay, and some more values, right? 18. Okay, so like this, we have some 6, 7 values, right? So the next one, let's have a strings. Let's have all the strings. Okay, and we will create one string after. And the last one, we have a LST3, and we again have a mix of, integers and decimals, right? So what we can give is some 13.2, 67, 23, okay, 89.6, some 34, say 21, 21, and 7.08, right? So again, 7 values, right? So we now have all the lists created. Now from the list, what we will do is we will create the data frame pandas data frame object, okay? So the way we will do is we will simply create the data frame object. So data, okay, we name it as data, and then pd dot data frame. And when you do that, you will already get the prompt here. And then as a parameter, what do I have to give? I have to give the names of the attributes or the columns, okay, the column name and the data for that particular column that we can provide in the form of lists, right? So say for example, the first one, the first column, we name it as column 1, and then we give it just like a dictionary. We give it as a LST1. Same way, we give the column 2 and then colon LST2, right? And the same way, we give a column 3 and colon, we give a LST3. So this way my data is being created, and this data, this object is basically of the type data frame. We will inspect that, okay? So let's just print this data and see what it throws, right? So we will have all the things. So this throws a bit of an error. Let's try to figure out why this error is coming, right? So basically what we will see is we have given the dictionary object, but we have forgotten the second braces, right? So we can just give the second braces, and now we have a complete syntax. So see how these three columns, column 1, column 2, and column 3 have been created, and we have fed the data in the form of lists. The first list had all integer values. We are getting all integer values. Second one has all string values. We are getting all string values. Third one has a mix of integer and decimals or floats. So what is being done is, as we know, it is being converted to a float data frame. Okay, so this is how we can create a data frame using the lists. Now let's explore certain functions in the lists, right? But before that, let me also tell you, so this is one way to create data from the lists, or the numpy arrays also we can do in a similar way. But how can we load the data from a data file? Let's look at it, how to do it. So we will see the code for loading data from your from your laptop or workstation to the Google Colab, and how to run it. Okay, so that's one thing we are going to see now. So for that, we have to import a library, files library from Google Colab, right? So from Google dot Colab, okay, Colab import files. Okay, so this is how you can import on. Sorry, it's somehow gets deleted. Okay, now what I have to do is I have to do a files dot upload. The moment I call this function, what it will do is it will invoke the the button or the functionality to choose a file, or rather to invoke the file open dialog and to choose a file from your desktop. Okay, so let's run this code and see what happens. So you will see that here you can choose the files, right? Or you can, if you want, you can cancel the upload also. So let me choose one particular file, appendicitis. This is a very standard file used by the machine learning community. We have uploaded the file to Google Colab. Now, once that is being done, the way to read the file is again very simple. What I can do is data1 is equal to PD. There is a function called read underscore CSV. Okay, so read underscore CSV, which can be used to read a CSV function, CSV file. So read CSV, and then I will give the CSV file name. What is the file name? apndcts.csv, right? So the moment I do that, I will get all the data uploaded in the data1, which is again a Python pandas data frame object. So let's do that and see what comes here. Okay, we will see that all the data from the appendicitis.csv file has been loaded to the data1 object, which is of type pandas data frame, right? So this is how you can create a data frame object, a pandas data frame object from the data file. Like here you have seen in CS from the CSV file. Same way you can also upload it from a MATLAB file or from an Excel file, from different types of files, right? So now what we will do is we will also take a quick view of how to do it from Spider. So this is how you can do it from Google Colab. You can do the same thing from Spider also. Let's open the Spider console and see that. So now I open the Python Spider console, okay, which comes as a part of the Anaconda package. So here, see, I have introduced you to another new library, which is the OS library. What is the OS library made for? The OS library basically gives you certain utility functions which you will need to do certain very important things. Like for the first one, you will see that we are trying to find out what is the current working directory that I am pointing at. Okay, because when you are trying to upload a CSV file or any other data file, you need to point to that particular location, or in the path you have to give the entire path where the particular CSV file is located. But before that, you need to find out where exactly you are pointing to. So let's simply run this code and see where we are currently focusing on. So at this moment, I am focusing at a particular folder, F colon working folder CSIT Python class, right? So now let me also try to do one more thing. So let me try to do a list dir. So basically it lists all the files which are located in the current working directory. So once I run this, I will get all the different files. So I can see that there is no particular CSV file located in that particular folder. So what do I have to do? Either I have to do a chdir or change directory, or I can copy the CSV file and paste it in this location, right? Or what I can do is when I do the read CSV, I can give it with the full path. Okay, so I will take the shortest thing here or do the easiest thing here. I will simply copy paste the CSV file in this particular location. So let me do that. Okay. So now I have done that. I have copied the CSV file in the respective location, which is like CF colon working folder CSIT and Python class, right? So now I will simply do the same thing again. Data is equal to PD dot and then the same read CSV, right? As we have done in the Google Colab. And here I will simply do apndcts.csv, right? I'll do the same thing, and then I will have to close it, and then I will simply do see the data which is coming in, right? So let me run this code, and I can see the data here, right? So this is the way I can simply point to that location where the CSV file is there, or I can simply copy paste the CSV file in the location that my current thing is pointing to, and then I can run the same read.csv function of pandas, right? So once that is being done, what we will do is we will simply go back to the Google Colab, right? Let me go back to the Google Colab. So here we were. Now, let me show you some more very critical functions which are required to understand the data, right? So the first one, if you want to figure out the dimensions of the data, the number of rows and columns of the data, you can simply use the data.shape. In NumPy also there was a shape function, right? So here the data that we had created from the list, it had 3 columns and 7 rows, right? So same thing is coming here, 7 comma 3. That means it is 3 columns and 7 rows. Now if you want to just retrieve the rows or just retrieve the columns, how can you do that? You can simply fetch it with the index, right? So I can just print it here. The number of rows is, and here simply you give a the data dot shape, and then you give the index 0, so that will give you the row part of it, right? And the same thing I can copy paste and run it for the columns also, right? So the number of rows is this, and the number of columns will be the index 1. And if I run this, I will simply get the number of rows is 7, number of columns is 3, right? Now, another very important set of functions, two functions. One is the data dot info, right? Info function. What does it do? It gives you some basic information about the data. So what are the data types? Is there a null value or not? So if you want to figure out whether your data set. So this is a very small data. Data 1 is a very small data set. But if you have a very large data set and if you want to figure out if there are any null values or not, so here you can use the info function and figure out, right? Like say, for example, if I simply use the same thing for data 1, you will see that certain function, certain attribute may have no, here also it's all non-null. So your attributes need to accept non-null values, right? So this is the thing. Now I have one more function which is called data dot describe. Okay, what is the objective of data dot describe? It gives some statistical, uh, I mean, what should I say, summarization, right? Say for example, the total number of rows, okay, the count of data, right? Then it also gives the mean value, the standard deviation, the minimum value, the percentile values, the maximum values. Again, you see column 2 is a string. I mean, all the values are of string data type, whereas column 1 and column 2 are either of integer or of float data type. So you will see for column 1 and column 2, it will create the description, right? For column and 1 and 3. But for column 2, it will not create a description because it cannot create the summary statistics for column 2. It has all the string values, right? The next utility function is, say for example, I want to find out the top 2 or 3 rows or the bottom 2 or 3 rows. How can I do that? Simply I can do a data dot head, and within bracket I can just mention the number of rows from the top I want to retrieve. Same way, if I don't give any parameter, by default it will select, if I just don't give anything, it will select the first uh, 5 rows. Okay. Same way, I can use the tail function. So data1 dot tail, and if I give say 2, it will give me the bottom 2 rows. Okay, the bottom 2 rows it will retrieve. So this is another very important function when you want to get a subset view of the data set, right? Next, there is one more important function which will, the function is, if I simply, I want to see the column names of the data frame object. How can I do that? I can simply do a data dot columns. Okay, and it will retrieve all the column names of the data set. See, column 1, column 2, and column 3, right? I can also use the columns dot values to do the same thing, right? and there is another option. I can simply get the column names in the form of a list. Okay, so if I give just a list and then columns, data1, data dot columns, it will return me the list containing all the column names as the different attributes. Now, if you just want to select the first column name, say for example, right? So if I give a 0, it will retrieve for me the first column name. So this is how you can just do a very simple thing. And one thing I missed out is if I want to see the data type of this data object, right? I mean, we know that it's going to be of type data frame, but let's just check that out. Okay, so if I do a type and then within brackets data, it will return the pandas.core.frame.data frame, right? So it's a data frame object, right? Now if I, so when I do a list data dot columns, it is going to retrieve me the lists. Now say for example, if I want to change the name of the column, of a particular column, so what can I do? Simply list dot columns, it can use both for getting the values of the columns or getting the names of the columns or setting the names of the columns. So I can use the same thing. So let me just pick it up from here. Let me just remove this, run this. Okay, sorry. I just run this one more time. I will get the list of column names, and here I pick this up and I change the names. Okay, what do I do? Instead of column, I give a attr1, and then I do a attr2, and then I give a attr3. Okay, and then I just want to be sure whether I'm really getting that. So I do a run on the data. So if I do this, now you will get the data set. What's the problem? There is some problem. So can't set the attributes built-in list. Okay. So there is a very silly mistake here. I should have named the data.columns. Now I can do this, right? So I can simply do this. Now, in case, so you don't want to change all the column names, so you just want to change one particular column name, right? How can you do that? So you can use the rename function to do the same. So you can just use the pandas rename function to do it. How do we do that? So data dot, sorry, dot rename, and then what you, and you give the column, the particular column that you want to change, so attribute 1, and then the changed column name, or what you can do is, since it is a string attribute 2, let's give it the attribute 2, right? And then again we will just see whether the change has been effected or not. Just remember, there is one parameter here, in place is equal to true. Unless you give this, what it will do is it will not reset the value of this particular data frame object data, right? It will not do it. It will simply do on a temporary copy of that data, right? If you want to apply the change on this data frame object named data, you'll have to mark the in place is equal to true, right? So this is how you can do it. Now say for example, you want to basically create a new column, right? How you can do it? You can use uh, the plus, the transformation function, right? So let's use data. Say for example, I want to create a new column, say new underscore attribute. Okay, and then here I just want to do a summation of attribute 1 and attribute 2, right? Sorry, attribute 3. Okay, so let's just give a data, and then I mark it as attr1, and then the same thing, I give a data and I do a attr3. Okay, and I see this, right? So now if I do this and I just look at the data object, see a new attribute. Okay, there is some error which is being thrown. Why is that thrown? attr1 and attr3. Oh, okay, sorry, I didn't give these quotes, and that's why it is shouting at me. Okay, now this is going to be created. Okay, you will see that a new attribute has been created, which is the sum total of attribute 1 and attribute 3. Okay, now say for example, if you want to remove this attribute, so I have added a new column. Okay, and now I want to remove the column again. How I can do that? I can use the drop function to do that. So let's use the data dot drop function. Okay, so data dot drop. Okay, and then within bracket we have to mention which particular column we want to drop. So let's drop this new attribute. Okay, so new underscore attribute, this column, let's drop it. And then we also have to mention which axis. So is it a row or is it a column? Okay, even if you have a index name assigned to a row, you can do a row dropping using axis is equal to 0, right? But here we want to drop a column, so we will use axis is equal to 1 to drop a column. So to drop a row, you use the same drop function, but with axis is equal to 0, and for column we have to use the axis is equal to 1. Okay, so we do this and then again check whether this drop has happened correctly or not. So when I do this, oh my god, this is not being done. So why is it happening like this? So again, the same way as I mentioned in the last case, so when we were basically doing this rename, so here also when we are dropping the data or the column, right, if you want to make that effective on that particular object, you have to use that in place parameter, and you have to set that in place parameter as true. When you do that, you will see that the column will be removed. Okay, so why is this not happening? Okay, so the true t has to be captured. So these are very small, I should say, irritating things you have to deal in Python. It's very case sensitive. Whenever there is a problem in the case, you will get such syntax errors. Okay, so here you will see whenever I used in place is equal to true, then the data, the column drop happened in this data object itself. What is the other option? We may not use this in place. Then in that case, I have to assign this data dot drop and this whole thing, that temporary thing which has been created, to another object, say data 2 or data 1, whatever. Okay, so that is the other option, right? So that is how you can drop the column. So you know how to add a column, you know how to drop a column, right? Now we will see how we can and how you can access a column. It's very simple. We have already seen that, right? Simply you can use the column name. So attribute attr1, and you can retrieve the column. In case you want to retrieve multiple columns at the same time, not a single column, you simply need to give it as a vector, right? As a set of uh, attribute names. Say for example, I want to retrieve the attribute 1 and the attribute 3. Okay, so how can I do that? Simply by doing this. Okay, I'll just retrieve the two columns, attribute 1 and attribute. So by the column name, I can retrieve the specific columns. And if I want to take this subset and do something different, I can simply assign this to another object and do whatever I want, right? Now, if you want to retrieve specific rows, I would say the simplest way to do that is by using the iloc function. Okay, what does the iloc function? It gets the particular row based on the index value of the row. Say for example, I want to retrieve the first row, so I will give the iloc 0. Okay, I will retrieve the first row of the data uh, uh, data object. Okay. So basically, I don't need this first bracket. I simply can run like this. Okay, I am retrieving the first row. Say, for example, we want to retrieve multiple rows. How do you do that? Simply, I can use the 0 colon. Say, for example, I give 3. So it will retrieve 0 and 1. The indices 0 and 1 and 2. 0, 1, 2. It's the same way like we did in case of sequence data, 0, 1, 2. Same thing if I want to retrieve the second and the third rows. So 1 colon 3. So it will get the 1 and 2. Index numbers 1 and 2. Rows with index numbers 1 and 2. Right? Now, if you want to retrieve the last row, say for example, how do I do that? Simply, I use the iLock with a -1, right? So that will retrieve for me the last row, right? So this is how you can retrieve specific rows and specific columns, right? Now, if I want to use certain conditions, okay, say for example, I want to retrieve, let me see the data, okay. So the data is like this. I want to retrieve all the rows which have the attribute 1 value greater than, say for example, 25. How do I do that? So I will use data and then square bracket. I will give the attribute name. So at attr1, and then I will simply use the greater than 25. Sorry, 25. Right. So that will retrieve the rows which have the values uh, greater than 25. Right. So I'm sorry. So here, and then I give uh, this, what is that, bracket, and here I give the attribute name, right? Okay, right? And greater than. So let me see what it comes. No, it's still showing some error. And the error is because I forgot to mention this data here. So data attribute 1. So I will get the specific indices here. And then when I apply the indices, I will get the specific rows. So row indices and the rows. So here now I get this. If I change this to say for example 12, I will get a, or say 17, I'll get some more rows, right? Now the same way I can also retrieve for say attribute 3. Okay, if I want to fetch, so attribute 3, if I want to fetch the rows which have value less than say 23.00 or 23, let me see. Okay, if I do this, I will get all those things. Now if I want to get uh, the rows which satisfy both the conditions, how do I do that? So that case I will have to use a and condition, right? How do I do that? Simply I copy this, okay, the first one, and then I do a copy of the second condition, right? And do a and here, and the second condition like this. So the first condition will give me certain indices, row indices. The second condition will give away also another set of indices. We will do an and, so we will get the intersection. And then when we apply it to the data, we'll get that specific set of rows, right? So this is now giving it. Now the same thing, you can also use the or notation to get the or, okay, any one of the conditions being satisfied, it will retrieve the rows. Okay, so this is how you can use certain conditions to retrieve or to filter the rows. Okay, it's like pretty much like the where conditions, where attribute 1 is greater than 17 and attribute 23 3 is less than 23, or where attribute 1 is greater than 17, or attribute 3 is less than 23. So it's basically for those kind of things. Now, if I want to see, say for example, the unique values, okay? Say for example, I want to see the unique values for the uh, attribute 1, okay? Attribute 1. So how can I do that? So I can simply do a unique, okay? I can do a unique of this, and I should get all the unique values. So I can see that there are some repetitions. So there are two repetitions of the value 12, right? And otherwise all the values are happening in a unique way. Okay, I mean occurring in a unique way. If I want to see the count of unique values, I can also do that in unique function. So it retrieves that out of 7 rows, attribute 1 has 6 unique values, right? Now, if I want to do a, say for example, I want to do a summary statistic based on say unique values. So I want to do a group by. So all unique values of a particular attribute, if I want to see particular statistics, say for example the mean, how can I do that? So for that, on unique on attribute 1, I will apply a group by. Okay, once I do that, the data is being grouped by, the rows are being grouped by the same values of the attribute 1 will come together, and when I do a mean of that, I will get the attribute value wise mean of the thing, right? So a small correction. So it will not be like this. So it will come as data dot group by, and then you give the attribute name, and then you do a mean of this. Okay. So like this, you will see. So 12, there are two particular rows. So one with a value of 13.2 and the other one with a value of 89.6. So it will do a mean of these two. Okay. And on attribute 2, it is not going to do any mean calculation because attribute 2 has all string values, right? So for string values, you cannot calculate the mean. So like this, you can do a group by and a calculation of the means. In case you want to do group by on multiple values, you can also do that, right? If you take a larger data set, say for example, I take the data 1. Data 1 is basically the appendicitis data set, right? So if I just look at it, head, and it's an appendicitis data set. So if I want to do a group by on say attribute 1 and the attribute 2, so how can I do that? Simply I can do a group by of attribute 1 followed by attribute 2. Okay, so AT1, that is the first one, and then you give, say for example, the 82 or 83, maybe also we can give 83, and the whole thing you need to give as a vector, right? And then if you do it, you will get the mean rolled up by the there is some, oh okay, so this is the data 1, right? So now it will get the mean based on group by for 81 and 83. So what is the problem which is coming here? I think there is some problem with the name. I'm sure the name is not exactly what we are giving. So let me do a data 1 dot columns. Okay, and let's figure out where it is going wrong. And what you will see is, okay, so 83, there is a space in the name. I don't know why, for what peculiar reason it is having this space in the name. So that is why it was showing an error. So now you will see it will roll up by 81 and then by 82 and give a mean of the other variables barring that last variable, which is what? Which is the string. So 87, if you just look at the 87, so I do a head of that, you will see that 87 is basically a string. It contains all the string values. It's a class. Okay, it's a class, right? So that's why it's not given. Now, once this is being done, we are going to move to the last part of it. Say, for example, if I want to figure out if the data contains any null value or not. So how can I do that? So data1 dot is null. If I execute this function, I will find out all the cases where the null value is there. And then if I use the same thing for data and then I use this is null, it will give me only those rows where okay, this should be data1, I'm sorry. It will give me only the rows where the null values are present. No, it is giving me the rows where the null values. So let me give not null. It's not giving me the right thing. So in data, for example, we don't have any null value, right? We have already seen that there are all, uh, valid values given. So that's why when we do a data dot is null in case of data, okay, uh, we are not getting any null value. All the values are coming as false, so it's not meeting the condition, right? And then if you can, if you just see, if you can use this same things and you can apply on the data frame object again, and you can retrieve the values which are missing, right? Or the rows which are missing values, right? So this is how we can find out missing values in the data. Now, other than that, there are certain utility functions which we can also use from the Pandas library, or rather it's a combination of Pandas and the NumPy library. So say, for example, if I want to find out the mean of a particular column in a data frame object or a data set. So how can I do that? I can simply get that column selected and then apply the np.mean or any other statistical function like np.median, variance, or standard deviation. All those things we can simply apply on the column which we retrieve for using the Pandas library, right? So this is all about the Pandas library. Again, I want to stress it. Whenever you want to work in machine learning, you will extensively use the functions of Pandas library, right? And as we come in the subsequent lectures, when we look at the different machine learning applications, we will see that. So in the next video, we will again come back and touch upon another very important library in Python, which is for the data visualization. So what you saw in this lecture is the data upload, data manipulation. Another very important aspect of data is the data visualization that we will cover in the next lecture, which is for the libraries matplotlib, and there is one more library built on matplotlib called the Seaborn library. Let's stay tuned and we'll look into those libraries in the next lecture. Okay, thank you very much.